Okay. So in series circuits, suppose if Z1, Z2, Z3 are in series, what is the equivalent impedance? In series circuits, if Z1, Z2, Z3 are in series, what is the equivalent impedance? Z equivalent is equal to Z1 plus Z2 plus Z3. If it is DC, R equivalent is R1 plus R2 plus R3. But in AC, Z equivalent is equal to Z1 plus Z2 plus Z3. Suppose in DC, if two resistances are in parallel, what is the equivalent resistance? R1 and R2 are in parallel. What is the equivalent resistance? If two resistances R1 and R, tell me. What is the equivalent resistance if they are in parallel R1, R2? If two resistances parallel. R equivalent is equal to
R1 R2 by R1 plus R2.
okay, R1 R2 by R1 plus R2. Suppose two impedances Z1 and Z2 are in parallel. What is the equivalent impedance? Z equivalent? Z1 Z2 by Z1 plus Z2. That is the equivalent impedance. Z1 Z2 by Z1 plus Z2. We'll do one problem in parallel circuit. See here. One minute, I am opening. Take down this problem. 14 example 14.1. Two circuits. Take down this. Here two impedances are in parallel. Write down the question. I'll explain the solution later. Two circuits, the impedance of which are given by Z1 is equal to this much, Z2 are connected in parallel. Write down this question. Your heading is parallel AC circuits. So heading parallel AC circuits. Parallel AC circuits. Write down the question. Take your calculators also. Take your calculators and keep it with you. After writing the question, inform me. I'll start the solution.
Completed.
Written?
Yes. Yes, sir.
Okay. We'll start the solution now. Okay. See here. Two circuits. The impedance of which are given by Z1. They are giving Z1. See here, they are giving Z1. Z1 is equal to 10 plus J15. Z1 is equal to 10 plus J15. Here, if plus J is there, what is this circuit? If plus J is there, what is this? If plus is there, it is XL. Now Z2 is equal to 6 minus J8. What is this? What is this circuit?
XC.
RC circuit. First one is RL circuit. Second one is RC circuit. Your second circuit is first circuit is RL circuit. Okay. Second circuit is RC circuit. J is given means it is reactance. If J is given means that is reactance. Your reactance is XL is 15. Your XC is 18. If minus is there, it is RC circuit. Okay. If minus is there, it is RC circuit. Now this Z1 and Z2 are connected in parallel. See here. First Z1 I am writing. This is your Z1. Z1 is equal to 10 and J15. Your Z2 is connected in parallel. Your Z2 is connected in parallel. What is Z2? 6 minus J18. Okay. This is your Z1. This is your Z1. This is your Z2. This is your Z2. Z1 and Z2 are connected in parallel. Okay. If the total current is, see here, total current flowing is 15 ampere. Total current flowing is 15 ampere. So this parallel combination is connected across the supply voltage. So in parallel, current will divide. In parallel, current will divide as I1 and I2. I is the total current. They are giving the total current. When you are connecting this parallel circuit across the voltage V, this current is flowing. This voltage is supplying the total current 15 ampere. This 15 ampere is dividing at this node point. In series, current is same, but in parallel, current will divide. In parallel, current will divide as I1 and I2. Now, what is the voltage across Z1 and Z2? Anyone? What is the voltage across Z1 and Z2? V. In parallel, voltage is same. Whatever the voltage we are applying, that entire voltage will appear across Z1 and Z2. In parallel, voltage will be same. V is equal, here I is equal to I1 plus I2. In parallel, current will divide. But V is equal to, V1 is equal to V2. In parallel, voltage is same. Whatever the voltage we are applying, the same voltage will appear across Z1 and Z2. Same voltage will appear across Z1 and Z2. Is it clear diagram? Now what he is asking in the problem to determine? What he is asking in the problem to determine?
Power taken by each branch.
Power taken by each branch. Let us take power in Z1 is P1. Power in Z1 is P1. Power in Z2 is, let us take P2. Power in Z2 is P2. We have to calculate P1 and P2. P1 is equal to I1 square into R1. Current flowing in Z1 is, what is the power P formula? P is equal to I square R. Power in the Z2 is P2 is equal to I2 square into R2. R2 is, what is R1?
10, sir.
R1 is 15 ohm, sorry, 10 ohm. R2 is
6 ohms.
6 ohm. So P1 is equal to real part only, I1 square into R1. P2 is equal to I2 square into R2. If you want to calculate P1 and P2, I want I1 and I2. I want to determine I1 and I2. If you want I1 and I2, okay. First I'll, for determining I1 and I2, first I will determine total equivalent impedance. See here. Have you written this?
Yes, sir.
Okay. Now see here, now I want I1 and I2. Remember this. For determining I1 and I2, first I am determining the total impedance. Before determining total impedance, see here. Convert this to polar form. POL 10, 15. POL 10, 15. Convert this.
Magnitude is 18.02.
18 at an angle.
56.30.
Okay. Let us take it as 57. In your textbook, they are giving it as 57. Approximately, it is 18 at an angle 57. Now, what is Z2? See here, POL 6, minus 18. POL minus is there here. 6, minus 18. POL 6, minus 18. Are you getting this?
No, sir. Magnitude is 18.97.
Second one,
Yes, sir.
Yes, sir.
Magnitude
how much?
18.97.
Okay. See properly. 18.97. Everybody getting this?
Yes, sir. Yes, sir.
Okay. You are getting 18.97, I think.
Sir, in question they gave Z2 is equals to 6 minus J8. You took
J8,
18,
sorry.
sir. That was,
J8 it is. Okay. Take it as J8 then.
now we are getting 10. Angle is minus 53.1.
Okay. In your text, in your question, it is J8 means take down. Sorry, I had written wrong, I think. I have written wrong. Take it as 8. In your circuit also take it as 8. 6 minus J8, sorry. I think now you will get 10.
Yes, sir.
Now I will determine the Z equivalent. Z equivalent is equal to Z1, Z2 by Z1 plus Z2. I will determine the total impedance. Z equivalent is equal to Z1, Z2 by Z1 plus Z2. Now see here, write down note point, note. In multiplication and division, take polar form for calculations. In multiplication and division, take polar form for calculations. Take polar form for calculations. Note point 2. In addition and subtraction, take rectangle form. In addition and subtraction, take rectangle form or Cartesian form. Take rectangle form. Now see here, Z1 and Z2, they are in multiplication or addition?
Multiplication.
Multiplication. Take polar form here. 18 into 10, that is 18 at an angle 57, 10 at an angle minus 53.1, divided by, addition is there in the denominator. Take rectangle form. 10 plus J15 minus, plus 6 minus J8. Now this will be 18 into 10, 180. 180. Now 57 minus 53. 57 minus 53.1 divided by 10 plus 6, 16 plus J7. Add the real parts. 10 plus 6 is 16. 15 minus 8, it is 7. 15 minus 8 is 7. So in multiplication, angles will be added. See, I am adding these two angles. In multiplication, angle will be added. 57 minus 53.1. If it is plus, here will get plus. So we are adding these two angles. In multiplication, the angles will be added. Now here I will get 180 at an angle. What is this? Angle, what is the angle? 57 minus 53.1?
4.9. 3.9, sir.
3.9. Convert this to polar form. Because numerator we are having polar form. Convert this into polar form. POL 16, 7. How much you will get?
17 at an angle 23.6.
Now 180 by 17. How much?
10.58.
10.58 at an angle. If angle comes to numerator, it becomes minus. 3.9 minus 23.6. If angle comes to numerator, it becomes minus.
Minus 19.7.
Okay. Minus 19.7. Ohms. This is ohms. Okay, now I have calculated the Z equivalent. Our Z equivalent is, I'm writing here. This is your Z equivalent. Now I will determine I1 and I2. Now I want I1 and I2. See here. I1 is equal to, in parallel current will divide. What is the current divide rule formula? I1 is equal to total current into opposite branch impedance. What is the opposite branch impedance for I1? For I1, what is the opposite branch?
minus J8.
It is Z2. Opposite branch. I1 is flowing in Z1. Z1 opposite is Z2. Total impedance of parallel branches. Opposite branch impedance by total impedance of parallel branches. Okay. I1 in DC will take R2 by R1 plus R2. But in AC we will take impedances. Because we are not only having resistance but also reactance is there. I1 is equal to I total current into opposite branch impedance by total impedance of parallel branch. Similarly, I2 is equal to total current into opposite branch impedance by, for I2 is flowing in Z2. I2 is flowing in Z2. Opposite branch for Z2 is Z1. Z1 by Z1 plus Z2. Okay. Now your total current is 15. See here. Your total current is 15. What is the opposite branch? Z2. In multiplication, take polar form. 10 at an angle minus 53.1 divided by Z1 plus Z2. We have already calculated Z1 plus Z2. What is that value? See in the Z equivalent, we have calculated Z1 plus Z2. What is this value?
17.17 at an angle 23.6.
17 at an angle 23.6. We have already calculated Z1 plus Z2. Okay. We have added and we have converted into polar form. Okay. This is Z1 plus Z2. Now all are in polar form. Multiply 10. 15 into 10 divided by 17. How much?
8.82.
8.8.
2.
Are you getting this? If your angle comes to numerator, what it will become?
Minus.
Minus 53.1 minus 23.6. Tell me the value.
Minus 77.
Minus 76.7.
I1 is this one. Now come to I2.
Minus
15.
77.2.
Minus
77.2.
One minute. 77 point. How much? 77 point.
76.7.
Okay. 76.7. Now I am calculating I2. What is Z1? We have already calculated Z1 plus Z2. That is 17 at an angle 23.6. Now tell me this value 15 into 18 by 17. How much?
15.88.
15.88.
88.
What is the angle? 57 minus 23.6.
33.4.
33.4 ampere. This is the current I1 and I2. Now we have to calculate P1 and P2.
So
Tell me.
I1 plus I2 must be 15, sir.
If you take I1 and I2, it should be 15. Take the I is the resultant of I1 and I2. Convert this into rectangle form. After that, you calculate, you will get 15. See here. Now convert this I1 into rectangle form. 8.82 at an angle minus 76.2. Please convert this and tell me what is the value. REC 8.82 comma 70 minus 77 minus 76.7. Tell me the value. REC 8.82 comma minus 76.7.
X is equals to 2.02.
X value how much?
2.02.
2.02.
Y is equals to minus 8.58.
8.58.
Yes, sir.
Now tell me this value I2. REC 15.88 comma 33.4.
X is 13.25.
13.25.
25. Y is 8.
Plus J. How much?
8.74.
8.74. Now I is equal to I1 plus I2. Take down I1 plus I2. Your I1 is 2.02. Add the real parts. 2.02 plus 13.25. Add the real parts. 15.27. And add the imaginary parts. Imaginary part is approximately 0. 0 point something is approximately 0. Is it okay?
Yes, sir.
Now see here I, what is the I value? Approximately are getting 15 because we have taken some decimal values. We have not considered some decimal values. That's why the difference is coming. What is your current? I is 15 ampere. Your current is 15 ampere. 15.2 means approximately 15. Your 15.2 means because some decimal values changes there. We have not exactly considered the decimal value. That's why the difference is coming. Is it okay now?
Okay, sir.
Okay. We can't add the polar form directly. I1 and I2. See here, your doubt is I have understood. You have added these two. 8 point, what is this? 8.82 and 15. But what about the angle? In addition, we can't add the angles. In multiplication, we can add the angles. That's why the difference is coming. We cannot add the polar forms. By converting into rectangle form only, you can add this. Okay. That is your I. Now come to P1 and P2. Your P1 I am calculating now. P1 is equal to I1 square into R. Your I1 is, what is the magnitude of I1? 8.82. While calculating powers, we have to take only magnitudes. Magnitude, this is, don't take the angle. R1 is 10. This is your P1. How much you'll get?
Triple 7.9.
How much?
777.92.
Watts. I2 square into R2. I2 square is 15.88. R2 is 6.
One five and 3.04.
15.
13.04.
Okay. 1513 watts.
So
Tell me.
if the resistance is present before the current splits, then how to calculate?
Not getting. If the resistance is
The current gets splitted no, sir, into I1 and I2. Before
okay.
that, if there is any resistance, then
Okay. That problem we'll do next problem. One more we'll connect in series here. Like this we'll connect. Let us take this is Z3. Your doubt is Z1 and Z2 are parallel. Now Z3 is in series with this parallel combination. Okay. The type of problem we'll see next problem. Okay.
okay, sir.
Suppose if there is Z3, what is the current flowing in Z3? 15 ampere. Because in series current, whatever the current supplying by this, the same current will flow in that one. We will see that. This is P1 and P2. Now what else he is asking in the, now tell me what is the total voltage V? V is equal to I into Z equivalent. V is equal to I into Z equivalent. Your I is 15. What is Z equivalent? How much you got?
10.58 at the angle
10.58 at an angle
minus 19.7.
minus 19.7.
7.
This is your V. That is 150.58 at an angle minus 19.7. This is your V. Okay. Now what he is asking? First bit is completed. What is the second bit?
PF of individual circuit.
Power factor of individual circuits. Power factor of the individual circuits. For Z1, what is the angle you got? Z1, what is the value you got here? Magnitude.
57.
57 angle. Magnitude?
18.
18.
18. Z2?
10. Minus 53.1.
Now, this is your phi 1. This is your phi 2. For RL circuit, your phi 1. Phi 1 is this one. Phi 2 is this. For Z equivalent, what is the value?
10.85.
10.85 at an angle.
Minus 19.7.
This is your phi. Phi is the power factor angle for the entire circuit. Phi is the power factor angle for the entire circuit. Phi 1 is for Z1. Phi1 is the power factor angle for Z1 for RL circuit. Phi2 is the power factor angle for the Z2 RC circuit. Phi2. Therefore, power factor 1 is equal to cos phi1. Power factor 2, individual circuits I am determining first. First circuit is Z1. Power factor is this one. Phi1 we know 57. Phi2 we know 53.1. Total power factor is cos phi. Total power factor is cos phi. Total power factor is cos phi. Now determine the angles. Cos 57. 0.544. It is leading or lagging? Leading or lagging? Lagging, because inductive circuit. In inductance, current lags the voltage. Next one is cos 53. Cos minus 53.1. That is
0.6.
leading or lagging? Leading, because it is RC circuit. In RC circuit, current leads the voltage. That's why it is leading. Cos minus 19 point. What is the angle?
7. 0.94.
0.94. Leading or lagging? I am writing leading. Why? What is the phi value in Z equivalent? Negative or positive?
Negative.
Negative. If it is negative angle, it is leading. In the equivalent, if it is positive, it will be lagging. See, in the first value, phi1 is positive, lagging. Phi2 is negative, leading. In Z equivalent, phi is negative. Negative means leading. If angle is, write a note, if angle is negative, it is leading. If angle is positive, it is lagging. Okay. Completed? Now we will verify your answers. Okay, listen here. See what is the Z1 you got. Compare your answer in your textbook. Your Z1 is 18 at an angle 57. Your Z2 is 10 at an angle minus 53.1. Next Z is 10.3 at an angle minus 20.4. What you have got?
Minus 19.7.
Okay, approximately same. Some decimal values may vary in calculations. Okay, magnitude you got 10 point something. What is that?
10.85.
10.85. In your calculation, while calculating, you got 10.8. But here they are getting 10.3. Calculations, a small difference will come in decimal values. That is not a problem. This is Z equivalent. Z is equal to Z1, Z2 by Z1 plus Z2. And your volt, see I1, how much you got? What is I1?
8.82 at an angle minus 76.7.
See here some difference is coming. 8.82. Because while calculations, while considering the decimal values, we got the difference. 8.58 at an angle minus this one. And I2 is 15. They have got 15.45. How much we got?
15.88.
15.88. See, difference is coming. Calculation difference, that is. Angle is 33.4 he got. They got 32.7. Okay, this is I2. and total V voltage we got, because okay, see, Z value got 10.58, 10.3 they got here, Z value. That's why the difference is coming. We got 158 point something, 150.58. They got 150.4 point this one. Okay. And angle we have got 19.7. They got 20.4. Now come to the powers. See the power P1. They got 736 watts, but we got 777 because the current we had taken I1 8.82. They had taken 8.58. That's why the difference is coming. And P2 is I2 square into R2. We got 1432. They have got this one. Okay. And come to the power factor 1, PF1, 0.544 lagging. Power factor 2, 0.6 leading. This is, they have not given leading, write it down as leading here. And cos phi is cos 20.4. There is 0.94 we got. We got 0.94. Okay, this is the problem. Now come to the phasor diagram. Now he is asking to draw the vector diagram. He is asking to draw the vector diagram. Write down note. Vector diagram is drawn for voltage and currents. Write down. Vector diagram is drawn for voltage and currents. Vector diagram is drawn for voltage and currents. Now we'll draw the vector diagram. See. So V is equal to V1 is equal to V2 because all are in parallel. In parallel, voltage is same. 1 minute. In parallel, voltage is same. V is equal to V1 is equal to V2. Now tell me, I is the resultant of I1 and I2. I is the resultant. If you add I1 and I2, you will get I. If you add I1 and I2, you will get I value. Now see here, I am drawing the phasor diagram. I am taking the reference axis, 0 axis. I am taking the reference axis, 0 axis. Now I1 you see 8.82. I2 is 15.8. 8 is greater or 15 is greater? I1 is greater or I2 is greater? Magnitude.
I2.
I2. I2 is greater than I1. Now if angle is negative, take clockwise direction. Take clockwise. If angle is positive, take anti-clockwise. If angle is negative, take clockwise. So now I am taking clockwise direction for I1. What is the angle? Angle is clockwise direction I am taking. Angle is 76.7 degrees. Let us take, this is I1. Take I1. I1 magnitude 8. Now take I2. I2 is 33.4. See, I am taking I2 bigger line than I1. I am taking I2 is bigger line than I1. Why means magnitude of I2 is greater than I1. Magnitude of I2 is greater than I1. I am taking bigger line. But with how much angle I am taking? 33.4. I am taking 33.4. This is I2. I2 line is greater than I1 magnitude. But angle is 33.4 plus. Plus means anti-clockwise. Minus means clockwise direction from this axis. Now construct the parallelogram. Construct the parallelogram for I1 and I2. So for I2, suppose this is 10 centimeter. Let us take 10 centimeter from I1 parallel line like this. These two are parallel lines. Those two are parallel lines. I2 parallel line is taken from I1. For I1, parallel line is taken from I2. For I1, parallel line is taken from I2. These two are parallel lines. These two are parallel lines. These two are intersecting here. These two are intersecting here on x-axis. So in parallelogram, join this. This is the diagonal. Your diagonal is I. Diagonal is I. In the parallelogram, see the diagonal. What is the I value? 15 at an angle 0. Your I magnitude is 15 at an angle 0. See in your problem question, they have given total current is 15 ampere. 15 ampere at an angle 0 I am taking. So on the x-axis it is touching. This I1 and I2 are intersecting on x-axis. This is the parallelogram. Okay. This is the phasor diagram for I is the resultant of I1 and I2. I is the resultant of I1 and I2. In a parallelogram, your diagonal is the I value. Diagonal is the resultant. Suppose if you take parallelogram, you see. If this is the parallelogram, this is the diagonal, this is your diagonal. Similarly here, in this is the diagonal. Your I is the resultant of I1 and I2. Okay. Now I am drawing V. Current is completed. Current is completed. Now go for V. What is the, for voltage, what is the magnitude? 158. Angle how much? What voltage? What is the angle for the voltage we have calculated?
Minus 19.7.
Minus 19. This is 19. Clockwise direction. For voltage, I am taking clockwise direction. Minus 19.7. And the magnitude, I am taking it as V. This is the phasor diagram or vector diagram. If you are having doubt, you can ask me. Now see in your textbook what they have given. First draw the diagram. See in your textbook. Now I am showing. This is the vector diagram they have given in your textbook. I1 is 77.4. I2 is 32.7. See, magnitude of I2 is greater than I1. I1 and I2 resultant is I. I is the, see, this is I. On x-axis, they are getting I value. I is the resultant of I1 and I2. And see voltage V. V is 20.4. In your textbook, they have got V is 20, but we have got 19.7 minus. So your voltage is minus 19.7 in clockwise direction. If negative angle means clockwise direction. This is your phasor diagram, vector diagram. So if you are having doubt, you can ask me. Okay, in the next class, we'll see Take down the assignment. Example 14.6 assignment. A similar type of problem is given here. You can do the assignment. 14.6 example 14.6 is the assignment to you. Note down the question number. This textbook soft copy I have already sent to you. If you want page number 563. Page number 563, example 14.6. Do it as assignment. One second. So one student asked suppose if the current is in the before that, this problem we'll see in the next class. Z1 and Z2 are parallel. These two are parallel and one in series, one it is connected. The parallel combination is connected in series. We'll do this problem in the next class. I'll show the problem. This problem. 14.3 you will do in the next class. See here, two impedances are in parallel and before this one impedance is there, Z3. Then what will happen? Then how current will divide? You have asked the question. We'll do this problem in the next class. That is example 14.30. We'll do this example 14.30 in the next class. Okay. Have you noted the assignment problem? What is the assignment problem number? 14.6. 14.6. Please note down that all these assignments you have to submit in the Google Classroom. I will share the link, Google Classroom. You can register later. First you do the assignment and keep it ready. Okay. For this assignment, I'll give 3 marks. For this assignment, I'll give 3 marks in the mid-exam and remaining 2 marks. Total 5 marks, 3 marks for the assignment, 2 marks for the attendance. For attendance, I'll give 2 marks. Total 5 marks from the mid-exam. Mid-exam 1. Okay. Note down the assignment numbers. Okay. Previous class also I have given one assignment problem. What is that number? Assignment problem number? It is 13 point something. Can anyone? Okay, 13.39 and 14.6. These two problems. And in first unit, I have given one transient problem. In unit 1, I have given one transient problem. These 3 questions, you write it in a white paper, convert it to PDF and keep it ready. Whenever I'll give the Google Classroom link, you can upload in there. Okay. Now I'll take the attendance. Wait for some time.
14.16 or 14.6?
Not getting 14.16
or 14.6, sir.
I will take that. .6 that is 14.6.
Okay, sir. Thank you.
Okay. Wait for some time. I'll take the attendance. 4 is absent, 33 is absent, 46 absent, 46 absent, then 52, 60 is present. Roll number 60. Sixty is absent. So these are the absentees. Now you can exit. I'm ending the class now.